Hello, friends. Of course, we are meeting after a long time. But yes, I remember what did we study in the earlier sessions. Now we are starting with one more session of derivatives. But just to brief you what we have studied so far. So we started with introduction to derivatives. Then we understood forwards, futures, options. Even we did some numericals of it. Strategies are going to be the next video. But in between, I wanted all of you to understand an intuitive relationship between the value of a call option as well as value of a put option, and we are yet to study the pricing of futures, call option, put option. That we'll cover up later on because that is neither tested in CFP exam nor tested in CWM exam. A CWM exam has smaller component of pricing futures, so we'll take a couple of questions and we'll do it, but that is towards end of it. But today, let us understand an intuitive relationship between the value of call option and value of put option. I'm just narrating the quantitative part right now. If you want how this equation has been arrived at, so that means derivation, then do let me know. In the subsequent video, I'll be happy to share all those things with you. But yes, today I felt that derivation will make the topic much more tedious, and many of you may not be interested in that. So let's begin with it. It's a put call parity equation. And in CWM examination, what you can have is you will be given all the relevant components and you are supposed to find out the missing one. That's pretty simple. So let me explain you this formula quickly. Now C0 is the premium on call option right now. S0 is the price of underlying asset, or I can also say spot price. This is the premium on put option right now. Now, this is something interesting. This is the exercise price. This is the exercise price, or we can also say strike price. Now, e raised to RT. Now, what does this mean? Exercise price, and then it is minus RT, in fact. So this is the present value of exercise price that we are finding out, and then we are subtracting with this two. I can also rewrite this equation this way, that C0 plus exercise price, because exercise price is to be paid in future. So that has been the reason we find out the present value of it, into e raised to minus RT. Now it's the exponential function. You can easily solve on your calculator. Let it be Texas or Casio. Both support this computation, of course they would. And that is S0 plus P0. You would be finding out present value factor. So what would you do? E raised to then minus R represents the risk-free rate essentially, and T represents the time factor. So say for example, it is 6 months, then I would consider 6 by 12, that is equal to 0.5. Right? Now say for example, a premium on a call option is, say for example, 20. And I'm supposed to find out the premium on put option using put call parity equation. An exercise price for a stock, say for example, is 200, and the present value factor is 0.98. That's the random number that I've taken. Spot price right now for a stock is 190. So maybe this option is out of money. As we understand, your strike price is more and the market price is lesser, plus P0. That is how you can find out the missing number. So in the same equation, you can play with it. Only thing is that you have to know how do you find out e raised to minus RT. So most of the times I have seen in CWM question bank and portal question as well as in examination that they either ask you to find out C0, right, using all this data, or they ask you to find out P0 using rest of the data. So that's very simple concept, a very like in a cornered way written in the textbook. So is the reason the students are not able to find out easily, but this is going to definitely help you out in examination and in your preparation also. So that's it for the day, and in the next session stay tuned because we are going to start with option strategies. That is extremely important for the examination, and once again this is very important for CWM exam, not at all tested in CFP exam. Fine. So, and do let me know if you want derivation, and do let me know for further doubts. See you in the next video. Bye, everybody.